Okay, welcome to this lecture. Now, today we are going to discuss the specialized single server Poisson model. That model is a particular case of the general single server Poisson model. We have long back studied the general single server Poisson model. And prior to that, we studied the pure birth model as well as pure death model. So in pure birth model and pure death model, we studied these models in isolation, means separately they were given the form of derivation as well as analytical interpretations. Later we combined these two properties of the arrival model and departure model to produce as a combined model that was the general Poisson Kevin model. In that model, we have seen a very important transition diagram. With the help of the transition diagram, we computed the expected inflow of customers at the node and expected outflow of customers at any particular node. That was the node number n. And then equalized in case of a steady state. We we got the balance equation. Thereafter, simplification and little bit mathematical manipulation, we arrived at very important formula that was the general Poisson formula of Pn. That is Pn is equal to, if you remember, the numerator had the all this mu n minus 1 to mu naught, and denominator was the numerator had the lambda and denominator had the mu, and later was the p naught. That I would like to show you that formulation, and the value of p naught was computed with the help of the total properties. Sum total of all probabilities is equal to 1. So in meantime, also we discussed the representation and characterization, or the notation model of the Kendall for representing the Kevin model. So that popular model was A oblique B oblique C oblique D oblique E oblique. So there were 6 letters which were characterizing the arrival process, the service process, the number of servers, the discipline, the capacity of the system, and capacity of the source population. From that point of view, we discussed the issues, and today we are going to discuss the Markovian single server model, that is the Poisson single server model. And why this is called, I had promised that I will clear and expose this very point at appropriate point of the time when we are going to discuss the single server Poisson model. Why we write, if you look at here, the single server Poisson model is written in this way, is expressed in this way, that is the M1 GT infinity. So why we talk about the Poisson here? We talk about the Poisson here, but what happens when we talk the Poisson here? Then something is right. Something is happening as here Markovian. So what happens that we say Poisson, but really we use the M, and M stands for Markovian. So M stands for Markovian means why we say Markovian. I had discussed this very point a lot and a great deal, that whenever we talk about the arrival of the customers, it is completely random. Now it is disease. If disease is taken place now, then COVID. So you or we cannot predict which person will be caught by the COVID-19 or virus. So it is completely random. So here we can apply the giving model. So if it is completely random, then it has certain property. If you remember and reminisce the previous lectures, then it has the one forgetfulness property. So forgetfulness property and this exponential distribution property was also following the forgetfulness property or memory less property, if you remember, that is popularly known as memory less property. So exponential interval time and service times follow the exponential distribution, and exponential distribution follows the memory less property. Similarly, the Poisson follows the arrival number of arrivals, that is the discrete random variable, and the number of surveys given, this is a discrete random variable, and that follows the Poisson distribution. The memoryless property is given by the Markov in the completely random situation. So therefore, this property, because of memoryless property, this distribution is being applied and engaged here in case of the Ewing model, and therefore this Markovian has suggested this basic idea. Therefore, it is not written as Poisson, because Denis Poisson was a great figure and a great professor. And I remember, I always remember his statement about his life that I like two things, only two things. First is the discovering mathematics, second is teaching mathematics. So you can think the greatness and the height of that person who is having the thoughts like this. So therefore it is known as a Markovian. We say Markovian, not the Poisson, and therefore here it is written Markovian. So in this way, you look at here MM1 GD infinity. GD is what? This is the general discipline. This is general discipline. And a specialized is what? That every term, arrival means Markovian, specialized. Service Markovian, specialized. Server, number of servers, one, specialized. GD. GD means, you can say, GD means general discipline. So if you want to put any discipline here, so it has no problem for this model. So you can put here P4, you can put here LE4, you can put here 0, you can put here priority, whatever you like, you can put here. And therefore, this one is very important here. The infinity is what? Infinity is the capacity of the system is infinity. If you remember nowadays, I take the one burning example, that is COVID-19. In this disease, any government is not saying that we are not able to treat the patients of COVID. Means the capacity of the system through the queuing model is infinity. So 10 beds in some hospital, 25 beds are arranged in some hospital. Somewhere the quarantine system is going on. Means that is just like a waiting. Waiting means uh, um, they are not in the waiting room of the hospital. They are somewhere else. But out of those, immediately if any disease has broken out in some person, immediately they join the queue for the treatment. So I mean to say, this is the best example that infinity is the capacity of our hospitals in service, providing the service. Similarly, the calling population is infinity. The source population is infinity. Nowadays, It is also true any person is coming from any corner of the country. So you can't say that our calling population is limited. Your calling population is not limited. You will say that I will treat the patients of the Ayodhya district only, and we will not treat other patients. The government will decide if the district Ayodhya has the facility equipped with all well-oiled machinery, well-oiled equipments of the medical science. Then the government will decide the patient will move from one place to another place. So, meaning thereby what I mean to say that the capacity source population is also infinity. So now this is characterized by the what does it mean that Markovian arrival, Markovian departure with general discipline means any discipline may take place here. Any discipline may take place here. Any discipline may take place here means that uh, uh, FIFO, if you prefer FIFO, if you consider FIFO in the given situation, you can any discipline. Similarly, the LIFO, CO, etc. And if you remember the previous discussion in generalized Poisson Q, what happened in generalized Poisson Q? I am taking you on the journey of the generalized Poisson. There was a very popular transition diagram, and out of transition diagram, we developed some relations. And we developed relations means by adopting the inflow and outflow of the customer at particular node, the general node was the nth node. And in the steady state, since we are following the steady state, therefore balance equation was obtained by us. And if you remember, nothing we got the closed form expression or the final general expression of Pn in this way, lambda n minus 1 and lambda n minus 2, so forth, so on up to lambda naught. As a denominator, mu n minus 1 and mu 2 and mu n. Remember here, for memorizing this particular formula, you have to keep in mind, here is n minus 1 and here is n. So you will start from n minus 1 and you end up to lambda naught. But you will start from here the n and you end up to 1. Here is also n, here is also n, because it is ranging from 0 to n minus 1, it is ranging from 1 to n. So number of data in terms of the data or in terms of the arrival, it is in both cases n, and this is P naught. And P naught was observed that it is the value which is coming out of the to sum total of the Pn is equal to 1 for single server. Now we are going to a specialized. We are going to a specialized. Our work starts today here. That single server, in case of single server, if you remember, reminisce and revisit your previous knowledge of the lecture, then we had started lambda n. Lambda n was what? Do you remember or not? Lambda n was, this is the arrival rate, remember, provided system has n customers. Mu n was what? Mu n was the service rate provided the system has n customers. Now this lambda n has become lambda, a particular lambda value lambda, and mu n has become n. So when n is equal to 0, then this is lambda. When n is equal to 1, this is lambda. When n is equal to 2, so forth so on, it is only lambda. So similarly, it is mu. So lambda n has become lambda and mu n has become lambda. This has become lambda when n in the system 0 customer, in the system 1 customer, so forth so on. So this has been specialized. Okay, this condition reduces the Pn. You look at here interesting mathematics, because we are mathematicians unless we get the dose of the mathematical formula or mathematical derivation, we are not, we do not seem happy or the internal happiness. has not come out. So now you look at this internal mathematics, how it is taking place. Lambda, this is lambda, every lambda n minus 1 has become lambda n minus 2 has become lambda n minus 3 has become lambda, so forth, so on. Lambda here was if you remember what, lambda naught. Lambda naught has also become lambda. If you want to write here, you can write here. This is corresponding to lambda naught. And how many times? Only data is, total data is now here n, so n times. Hope you are getting my point. And mu. Similarly, the mu last is also mu, but how many times? How many times? N times. And therefore, lambda power n, lambda to the power n, mu to the power n, and p naught is here. And then this is ultimately the expression for p. Okay. Then here little bit this PDF is not very lucid, but it is okay. We will do our work. So lambda mu is assumed here rho, and the rho is less than 1. So lambda, okay. This for a steady state condition, you look here. This is very important. This point is very important. Rho, so Pn is equal to rho n into P naught. N is ranging from 1 to 3. This is the steady state, because every derivation, every analytical discussion, interpretation is taking place under the steady state, and the steady state says that lambda is always mu means service, so it is higher than the arrival rate, then and only then the steady state or balanced state will take place. Otherwise, this will not take place. Okay, let us determine P naught. P naught is a value which we need to determine. How we determine, as usual, from B, we can write this part. N is ranging from 0 to infinity, Pn and 0 to infinity, rho n, and P naught. This implies that you look here, the P naught, the rho naught, P naught is taken outside, and this is Pn. So, this is rho n is equal to, since this is a total probability, so this is equal to 1. You can put here is equal to this, equal to here, this like this 1. It has no problem if you want to put, but it is written in another way. And this is 1 now. Then we expanded, elaborated this part of OM. This is equal to 1. Here is the formula we are going to apply. This is a geometric space. Here the A on 1 minus R. This formula is applied whenever the rho is less than 1. We were very, fond of, you have been very, we had been very fond of this kind of formula when we were studying from the lower classes or lower standard. So I have put here A is equal to 1 is here, and 1 minus rho R is rho. So is this equal to, so P naught here, we just, this will go upside. So P naught is 1 minus rho. So value of P naught has been obtained from here. Since P naught is less than 1, since P naught is less than 1, the geometric series, which one is geometric series rho n, converges. This is a mathematical analysis. This is the analytical discussion is taking place here. The analytical interpretation is taking convergence. If you do not follow the steady state, this series would not converge. Then you can think of, if series is not convergent, why we study the convergence and divergence of the state and sequence? We study the convergence and divergence of the series and sequence because of this. If it is diverging, it is not what the application in particular system. If it is diverging, we are going to leave it. If it is converging, then we have to analyze and interpret the situation and application. So here, if it is diverging, then what will happen? Nothing will happen. Every system, I mean, this system of the analytical system, mathematical system will collapse. It is not going to diverge, and therefore the steady state is very important for the mathematical interpretations as well. So, okay, this same thing, it is Pn only exists. In other words, we can say that Pn only exists if service rate is greater than the irregularity. Finally, forms the basis for steady state. Look here, this is the formation or the basis for this one, and therefore this is important to discuss this situation. Okay, let us go ahead. In this situation, we have obtained a closed form general formula. Simplified form. Closed form means that has been closed for simplification. That is, we know this is the mathematical term. Remember this term. Closed form means nothing is possible as a calculation, simplification, and manipulation. Now, the final stage that is known as a closed form, general formula. Since this is a general formula, therefore it is a closed form, general formula. In this situation, Pn is equal to 1 minus rho and rho to the power n. This has been obtained, n is 1, 2, and this has taken place. This is a general formula for this. I think here is 0 is also here. It is left. We have to check here. We check what happened. In MM1 model, this is similar to geometric distribution. Do you remember the geometric distribution? You do not remember. It looks like a geometric distribution. Here, in that very case, here is K and it is free from K, and so it is one is P and one is Q in case of geometric distribution. So Q may be written 1 minus P, and therefore from that point of view, it resembles the geometric distribution. So you remember this formula, and in your examination also, I have seen the previous year papers, some papers, they also ask sometimes the derivation of this formula. Now later, at the later part, we will discuss your problems now. First you listen this very discussion. So this is most important formula of Pn, expression for Pn, that is the main character which is playing role in the computation of the performance measure. You remember this very point that we had discussed the performance measures, which is popularly also known as measure of effectiveness and operating characteristics, or the measure of performance, measures of performance of the system. So there are several names of this, but in case of general Poisson Q, in general Poisson Q, we did not dwelt upon the simplification and calculation of the performance measure. We only just showed the concept or the formula. Only we gave you the basic formula or the basic concept, basic idea. But here we have computed the final stage formula, which we are going to be applied in our case studies or in application, etc. Nowadays on the tube, YouTube or on certain platform, people are only using the formula, but that is not our case. We are the PG postgraduate students, so we must know the derivation of the formula. Only the formula will not help you for the application, because unless we derive the formula, we do not have the internal knowledge of the application of that formula. Unless we know the genesis, how it has originated, how this has been derived, how this has been applied, and in where and in what situations this formula will be used. By that time, till that, our knowledge is not sufficient and complete. Okay, so we discussed the first performance measures. We had discussed, if you remember, how many performance measures we had discussed. We had discussed 8 important performance measures. We had given the idea of 8 important. And 2 important performance measures, which are 7 and 8, are not given in most of the standard literature, including the Professor Hamdi Taha has also not touched upon these formulae, because regions may be different. I would not like to comment on any status of the knowledge or any capability of any person. This is very bad thing. But anyway, these two things you will not found, 7th and 8th, but these two are most important for the, if you are going to apply the Kevin models. Okay, if you are going to pass out your examination, it's okay, you memorize these derivations, you just make the practice of derivation of these formulas. But so far as application is concerned, the 7th and 8th, uh, these performance measures are very important, particularly in case of research and this the project. So we will do a number of things. You can look at the students who are my students in the project advisor, and whom I am, whose advisor is me. So you can, we will discuss later how we apply, we will conduct the project on this giving system, giving model. So you look at here LS. LS is what? LS is the expected number of customers in the system. Either you write EN, either you write LS, and the formula I had given, I have applied the same formula. This is the variable, this is the probability. Pi, Xi, if you remember, Xi, ranging from 0 to infinity, and then N is here, and Pn is this value. This is rho n, this is rho, this is rho. So here in the second step, 1 minus rho is taken here, rho is put here, and n rho n minus 1. This one row is taken with power 1, and n p minus 1 is made in this way. This is adjustment, mathematical adjustment. So mathematical adjustment, so this very value may be written for this. I think you do not have any of this. Some d, p, o, and rho n is nothing else, but when you derive derivative, you take the derivative, you will find this expression. Okay, 1 minus rho, and rho is taken outside, and d o is also taken outside. So summation over this rho n, this, it is going to be this, and apply the same thing, geometric series, you will find answer is this one. So 1 minus rho, I have clearly made this uh, step by step, and 1 minus rho, and rho is here. When you differentiate this very part, what will take place? This will go upside, so this has the power minus 1, so minus 1 is here, 1 minus rho, and this will be minus 2. And if you differentiate this part, then this is minus 1. So in this way, 1 minus rho into rho upon this will come as a denominator and come down, and this will be plus including this. So rho upon 1 minus rho. So expected number of customers in the system is what? Expected number of customer in the system is this much. So LS is equal to this. When you more simplify lambda upon mu, simplify, ultimately LS is equal to rho 1 minus rho is equal to either you write this formula or you write this formula lambda upon mu minus lambda. This is the expected number of customers in the system. Unless we know that how many persons are in the system, how many patients are in the system, we cannot effectively and efficiently manage the system. So this formula is not a manager, but this is a tool. This is a helping knowledge for the manager. So manager is knowing that we have 50 patients in this hospital, then he will manage the 51. If I say the expected number of customers tomorrow will be this much, then he will be ready for the further management, efficient management. Okay, now come to the second one. In Kanti Swarup, if you look at, they have written each and every formula for this derivation in different way. They have applied the same formula. They have put n, the same formula. If you remember, they have said it, e, this is e to the power, this is expected m. Kanti Swarup treatment time, that book treatment I am just telling. They say m. They say m, and m is nothing else but the m is equal to m minus 1. They have started from m is equal to n minus 1. So they have, and the Kanti Swarup literature apply the same formula. Yeah. The same formula, if you look at the same formula of what? Formula, they say this is n minus 1 and this is okay. Then they adjust this formula and they apply the same thing and they come to the answer. But this is the another treatment, another knowledge you are, it is simpler, it is much less time taking, and therefore LS is here. Then we have a one formula, if you remember, a very prominent Professor Little. LS is this formula, lambda is equal to WS. So WS, you compute the WS first. This is LS upon lambda. Lambda you are given, LS we have computed. We simplify it. So 1 minus mu minus lambda. So immediate after computing the LS, we can easily compute the WS, that is waiting time per individual or per customer in the system. So here WS is equal to 1 upon mu minus lambda. This is what? This is the expected waiting time in the system. What? Per customer or per patient. So first is obtained, second is obtained. And unless you know the waiting time, you cannot take the decision. Okay, number is very high, Q is very high, then immediately what you do? Immediately you ask that what is the waiting time? You tell me half an hour, 2 hours, 3 hours, 4 days, 3 days. If person is say you won't get your number even in 1 week, immediately you take the decision. So this kind of knowledge, this kind of tool we provide the tool because we have tool and knowledge both. But nowadays, what is happening? People are saying that only tool can revolutionize. No, unless you have knowledge, that tool in isolation, tool alone cannot revolutionize the knowledge area. Tools plus knowledge. The teacher has tools as well as knowledge. The persons who have only tools and not having the adequate knowledge, they cannot revolutionize. People are saying online education is very good education. No, it is not. This is helping us. This is helping us. This is not mainline. This is only top up. This is only add on. This is only for the skill. We must know the application of this technology. No, but this is not the main line. Education. Main line is what? Main line gives us the what? Santulan. Main line gives us what? The sampurnata. Main line of education gives us what? Campus education gives us जीवंतता. ये तीन चीजें कहीं नहीं मिलेंगी ऑनलाइन में. हाँ ठीक है, आप खुश हैं, साइकिल नहीं चलाना पड़ रहा है, बस पर नहीं बैठना पड़ रहा है, बट दिस इज नॉट ए हेल्दी सिस्टम कि मोबाइल पर कई कई घंटे. अपने बच्चों से फीडबैक में अभी ले रहा था कि कई कई घंटे आप मोबाइल पर पढ़ रहे हैं. नो नो, देश शरीर माध्यम खलु धर्म साधनम. जितने लौकिक अलौकिक कर्तव्य हैं, कर्म है, सभी शरीर से पूरे होने. आँख ही आपकी पहले खराब होने वाली मोस्ट मोस्ट प्रीसियस ऑर्गन ऑफ द बॉडी. आप क्या पैरवी हम करें शिक्षक होकर के कि ऑनलाइन इज वेरी गुड. नो, it is good only 25% you use it. Okay, anyway, this is another discussion. So you got this very point. If you got this very point, it is decision you can take it. So I think today is enough, and now we are going to open it for discussion. But I just look here the question.